the opportunity to give us a little presentation. So this talk is aimed at taking people from knowing nothing about blockchain until what we're doing. So before I start, who here actually knows fundamentally how blockchains work and how, from a technology point of view? Okay, you could all be quite bored for the first few minutes of this presentation, so we'll go through that reasonably quickly. Okay, so my name's Martin. I'm the CTO of Siccar. Siccar's been around for a few years now. They're a blockchain technology company focused on data sharing. I joined the company about 3 months ago, so I'm new to this part of the world, so please forgive the accent. I've been around, I've been doing blockchain for a few years now. Started cutting my teeth on Solidity back in 2018, and then spent a fair bit of time in other sort of technologies. Did some time in Cosmos, with Golang, and now I'm in Rust and Substrate. So I'll go through this reasonably quickly, but the thing I really want to make a point of is we're not a crypto company, right? So when we talk about blockchain to people, a lot of people, when they hear blockchain, their first instinct is crypto, right? There's really two types of blockchain projects out there. There's all the public crypto ones which you hear a lot about, and then there's a lot of stuff behind the scenes in corporate enterprise land where they're using blockchains to do some cool stuff, and those you don't hear about so much because it's back-end technology, and it's not really important for them to publicize that, right? So, we're a blockchain company, but we're not a crypto company. We do focus more on the enterprise space, but blockchain is what will hold your wallet keys if you lose your passcodes, right? So it's definitely, the technology is what intrigues me the most. I mean, I think this is a technology which, when you think about it, the principal use case back in the day was some fairly nefarious people being able to transfer funds to and from each other in a very trustless way. If there's ever a group of people who, if they could screw you over, they would, that was the group. So the technology, having survived that crucible, is pretty cool. So yeah, so it is, the thing that we focus on mostly is it's pretty much unhackable, right? It's very cool. Having said that, humans are involved, and humans do stupid things. Okay, so it's a if you happen to pass on you forget your password or whatever, and you hand your keys to someone else, they'll access your funds. And as Rita said before, she likes the banking system because you can go and get it if someone does something naughty. Using blockchain, once it's gone, it's gone. And blockchains are expensive. They cost a lot of money to run. I mean, the reason why the crypto world uses incentives to get validators to come on and actually run nodes and get rewards for running nodes. Running a blockchain completely by itself or across a network is many hundreds of nodes can add up in terms of compute. But they do a few things really, really well. So quick recap for those of you who perhaps aren't quite so familiar. I mean, the first thing, they're very resilient. The classic sort of centralized, decentralized, distributed architecture. We know that centralized, take out the middle node, everything's gone. Decentralized, take out some of the satellite nodes, a large part of it goes. Whereas a blockchain, you've got to take out virtually every node for the chain to go down. They're very tamper-proof. If you have somebody come along and try and tamper with this thing, then our wonderful friend Consensus kicks in and kicks them out, and they're gone. And they can rejoin if they are allowed to. So tamper-proof is a massive advantage. Very secure, everything is done with keys. All the nodes talk to each other, sign transactions between each other, signing with keys, and humans need to have keys as well. It's very auditable, which is the key thing for some of our clients, is being able to see everything that ever happened on this chain, knowing full well it hasn't been tampered with, and so therefore you can go through the logs and see exactly what happened, and no one can change that. They're smart. We have the ability to write some pretty clever code that runs on nodes, and can do some, some really, basic software. So whatever you can dream of within reason, you can execute on the nodes. and they're scalable. So there's no real issue in terms of being able to manage compute. So what's the big idea? I guess for us it's all about the data. I mean, to be candid, there's no such thing as a token. There's a ledger with a balance, a number, and a wallet address, and that's it, right? So cryptocurrency is all about storing these transactions, and no one can change them or tamper them. So it's all about the data. And we live in a world of data silos right now. So we have government institutions, we've got healthcare systems, we've got banks, we've got utilities, you name it. A lot of these companies store all their data in these silos, and they're taking very much a perimeter defense approach to life. So they have the data, they don't want anyone to get into it and hack it, and so traditional software systems rely on, firewalls and perimeter security. You've got all kinds of intrusion detection, two-factor authentication, all that kind of stuff to try and keep people out. Sadly, though, we know that sometimes these silos have problems. So hackers do get in, and when they get in, it tends to be a bit more of a free-for-all, because now they're in, they've got access to a lot of data. And that is definitely an issue. So, I mean, the silo kind of worked okay when these silos were independent, and so we had companies just had their own data, they didn't need to know anything else outside their silo, and that was it. But nowadays, I mean, it's still annoying to interact with them. You have to log into the bank and give your date of birth and your full name and all this kind of stuff and prove who you are. And go to the telco, do the same thing. So it's annoying for us, but that wasn't really their issue, right? But more and more, companies need to share data. It's becoming much more of an issue, and we're seeing that a lot nowadays, and we'll get into that in more detail in a second. So how do they share data? Well, there's lots of ways. I mean, we've got emails flying around, people are storing data in drives, in Google Drive or some sort of shared drive somewhere. You've got documents flying around. If you're lucky, you might have an API between your company and some other company. So it's a mess. None are very good. So, I mean, typical examples, the issues we have here are with emails. Once you send an email, you don't know where it's gone, who's forwarded to, you've lost complete control of the data there. Word documents, particularly in the legal fraternity, what version do I have? Do I have the most up-to-date version? APIs are expensive to integrate. You go to something like Salesforce, you've got vendor lock-in now. People might say, come to our website, enter your data that way, or upload it that way. Well, you've got data entry errors. So it's a mess. So why are they doing that? Well, partly is inertia. There's just so much infrastructure, so much money has been invested in these silos that it's extremely hard to change, and it's complicated. I mean, you've got all kinds of crazy, security systems and firewalls and protocols and business processes on top of that. So opening up your firewall to someone else, or opening up your data into a silo to someone else, is complicated. It's expensive because you've got to get really clever people involved to actually help you do it. You don't necessarily know if you trust the other company you're opening up your system to, is sharing your data with. If they get hacked and someone gets inside their perimeter, now there's a potential they can get into yours. And frankly, there's been no real incentive to do it. There's been no real reason to do it other than just it would be nice to have, right? But changes are coming. There's more regulation and governance requirements coming up, which is forcing companies to share data. I won't go through this entire list, but there's a few notable entries here. In the ESG space, there's something called Scope 3, which is when, at the moment, companies, when they need to report their carbon emissions or their greenhouse gas emissions, they just report on what they're generating in terms of their CO2 or whatever. But Scope 3 means that if I'm a company and I've hired someone as a trucking company to ship goods on my behalf, I now need to report on the CO2 they generated for me, right? And similarly, if I'm doing something for someone else and I'm generating CO2 on their behalf, I need to share that data with them about how that was generated or how much I generated for them. And that's sensitive information. I mean, it's not like financial records, but I mean, you're sharing details about how much, stuff you're pumping in the atmosphere. This is important stuff. So you don't want to share it willy-nilly. You don't want it to be out there just anyone to see. And there's other examples too here. I mean, telcos, there's various European Union directives coming out on board. And there's many more, right? So this is becoming more of an issue for companies. So how do we do that in a blockchain way? So single source of truth is the answer here. As you would have seen before from another diagram, data's flying all over the place. You never quite know which is the true source. So the aim here is to have a blockchain which the companies all just point to the blockchain. Company one, let's say they do some design work, they put the data into the blockchain, that's the single source of truth. Company two comes along, they need to look at that, and then they can access that. And everyone knows where the data is, everyone trusts the data, and it's shared appropriately. In fact, we're doing something like this at the moment with one of our clients. We're working with a consortium of about 4 or 5 companies, and we're working with a company to help build, we're 3D printing lighter ships, right? So we're using, they do some clever stuff with robots, a bit like those ones out there, and printing new ship parts. Now, how does blockchain help with that? Well, what happens is that when they 3D print these parts, they want to be absolutely sure that that thing was printed correctly and accurately. And so we take all that data from the welding robot and we stick it in the blockchain, and then down the track, Lloyds, for example, who need to certify that this ship is seaworthy, they can review that data and make sure that everything was kosher in terms of how it was built. And so they need to be really sure that the data hasn't been tampered with. We need to get data from various companies to pull together that package together, and we need to be able to make sure that only the right people can see it, because it's sensitive information, obviously. So that's the blockchain way of doing things. Now, in terms of how we secure that, so the difference here is that the data is encrypted at the file or record level. So if a human who is fallible were to let their key out of their possession and some bad actor gets in, you're not exposing the entire blockchain. All they can see is the bit of data they've got that key to, right? And even that can be limited as well, okay? And then what you do is the companies can share access to that data by sharing keys. And so those keys can be given out or taken back as required. And the key thing here is no key, no sharing. So there's a real reassurance that the data is there, but it's only visible to people who actually have the permission to do it. Most blockchains today, all the data is in clear text, and so there's nothing like that out there on the public network as far as I'm aware. So how do we encrypt the data? Well, we can do the multi-sig approach, but the trouble is with that is that if you want to add a key, you need to re-encrypt the entire data set, so we don't do that. You could wrap it in a smart contract and have keys associated with that, but the challenge there, of course, is it's a bit clumsy and a bit clunky. What you really want to do is have this data sharing layer which allows you to add and remove keys easily. And the key thing here is, pardon the pun, the main thing here is that the encrypted data set remains just encrypted once. You don't want to keep re-encrypting data and, oh, this is now version 2. No. You encrypt it once and then you provide and remove access as necessary. So how do we do that? There are a number of different ways to do it. This is one particular method. So ciphertext policy, attribute-based encryption, just rolls off the tongue, doesn't it? This is a way where you essentially have certain data encrypted, and then based on the attributes that you have, allows you to see it or not. So in this case, we have a central authority, and they generate a public key which is used by anyone to encrypt the data, and there's a master key for generating user keys, and then the person who wants to encrypt the data takes the public key, and they have a policy which they attach to that data, which could be something like this, where the role has to be manager and the department has to be sales. So that policy gets encrypted with the data, and that block is called a block of ciphertext. And then what happens is that the authority will then issue some keys with to various users, and those keys will also have their attributes assigned to them at that point. And so that means that when Alice goes to decrypt the data, because the policy says her role as a manager, that she needs to be manager or sales, and her attributes are manager and sales, it decrypts fine. But Bob, you're only an associate, you're not a manager, so you can't get to see it. Now, there is a problem here though, and that is a single point of trust. Because if a bad actor gets in and takes over the central authority, then they can issue themselves keys, which is not good. And so we take a more blockchain approach to this, and we then use a decentralized authority, which essentially is a set of smart contracts which gets together a number of nodes to actually do the generation of the public key and the master key. And it also issues these authority keys. So an authority key means that you as an authority can now issue keys to users that you have data you want to control access to. And so with this new approach, the authority can now generate user keys and give out to users. Users can then request attributes. So I want to be recognised as a manager, I want to be recognised as a member of the sales department, and the authority decides if that's true or not. And so they'll then issue attribute keys to those individuals. And so the sender still encrypts the data the same way they did before. They take the public key, they take the role, they take the public key, they have the role, and they encrypt the data, and that's how it happens. And then what happens now though is that when Alice decrypts, she has two keys, a user key and her attribute key, which has her attributes with it, and that then gets tested against the policy, and then and she gets that data back. Whereas Bob still is only an associate, and so he doesn't. And look, that's not the only game in town. There are other ways to do this. I mean, you can wrap this in zero knowledge proof, you can add access control lists, and you don't have to use attribute encryption at all. You can choose some other mechanism if you wanted to. But this is the way we're doing it at the moment at Siccar. I'm going to just pause there for a second. Any questions or thoughts or comments? Or yeah, go for it.
Yeah, where it can be applied now? What do you think?
So where's being applied? Well, remember this back here. Yeah, so this is what we do here, right? So we have the authority would be company 1, authority company 2, authority company 3. So the authorities, so we have, so the consortium, the decentralized authority would issue authority keys to various companies, and then the companies would then issue user keys to their staff, and those staff then would request, if they need to access some document down here, they say, I need to be given an attribute of whatever, manager or engineer or whatever it is, and so they would then request that attribute, and then the authority would give to them, and then they would then be able to see the data. Okay. So this is, so, and the beauty of this is that this data here, once it's encrypted, stays encrypted. Okay. So the policy itself is what determines who can see it, and then the authorities can determine